Have you seen the argument with cancellation token like this or like this? And have wondered what that is? Today we are looking into it. Let's get into the code. In this example, we are creating an HTTP client and are sending a request to a web server. In the argument list, in the URL, you can see delay equals 1. That means the web server is going to delay the response until 1 second has passed. Before and after the request, we are writing something to the console so we can see how long it actually takes. We are doing this in a loop, so when we actually start it, you can see apart from the first request, which for some reason takes a bit longer, we get a response every 1 second. And currently there is no way to cancel this until we explicitly close the program manually. So let's see how we can actually cancel this with some logic. In this one here, the code is mostly the same, except for some condition on the bottom. We are getting some random value, and when it matches 1, we are breaking the loop, so we exit the program. When we actually run it, you can see, with some luck, that we actually get to cancel this loop. But if the response takes longer than 1 second, so we hope that it's gonna take 1 second, but it might take 30 minutes or so. Even in this one, we have no way to actually cancel the request itself. We are just canceling the loop. And here we are going to look into the cancellation token next, because there we can actually cancel the request itself. Let's look at this one. Here we are also creating an HTTP client and are still sending a request to this server. But now we are using a delay of 30 seconds instead of 1. So we have plenty of chance to cancel this request and actually see it. So what is new? We have this cancellation token source here and a parameter that is called milliseconds delay with a value of 5000. So this one is going to cancel this token that is attached to this token source after 5 seconds. And in the argument to get async, you can see that we pass the token of this cancellation token source. Internally, the HTTP client is going to cancel this request after this token has fired, which is after 5 seconds. And if we actually run it, you can see that after 5 seconds, the request gets cancelled. But what happens? There is an exception. Oh, okay. Looks like we have to do some extra work when canceling something. Let's look into this next. The only thing that changed is the delay that we now have with 2 seconds instead of 5 as before. And we have a catch block and we catch the operation cancel exception. If you have looked closely, you might have seen that the exception that was thrown was a task cancelled exception. But task cancel exception is a subclass of operation cancelled exception. So that's what we are using here. When the catch block is entered, we are writing some message to the console so we can see that the request actually was cancelled. And as you can see, when we run it, we see the text too slow and no more exception. Now, this is all good and fine if we are dealing with external APIs that we can supply with a cancellation token. But what about our own APIs? How can we write our own APIs that use cancellation token support? This example is a little bit more complicated than the ones before, so let's go through it. First, I create 4 order objects, and then I create a cancellation token source that is cancelled after 3 seconds. I supply both of these to a process orders async. In this method, we are looping through all the orders one by one, and we are having a mix of async code and sync code. So this should be representable for some real-world scenario. So this save to database async method does not really do anything new. We've already used this task delay before, so that's what I'm gonna use again, just to simulate some async work. But crucially is the expensive sync code that we want to support with cancellation. So before and after, I have this call to throw if cancellation requested. And this one in turn checks if the cancellation token was asked to be cancelled. And if so, it will throw this exception we have seen before. So if we run this, we can see that it actually cancels after some time. Not all 4 orders are processed. As you might have guessed, this cancellation is cooperative. So when you say throw if cancellation requested, it will throw an exception. But as a caller, you can't expect that the cancellation is actually resulting in such an exception. So the code might actually finish, or it might not even respect your request to cancel it. So in this example here, we have two using blocks, one with cooperative async and one with uncooperative async. In one scenario, we are respecting the cancellation, and in another, we are not. So you can see in the cooperative async variation, we have this throw of cancellation requested, and the uncooperative async we do not. If we run this example, you will see that one does actually cancel and the second, the uncooperative one, does not. So as a caller, you do have to expect that the callee will finish. One thing you can do is create linked tokens. So when either one of them fires, the operation is cancelled. So in this example, we have a patient async method, which cancels after 30 seconds. And this token is supplied to the impatient async method, which only wants to wait for 1 second. So it calls this create linked token source and supplies this token from the outside, and then calls cancel after with 1 second delay. And the do work async will wait indefinitely, but since we supplied the cancellation token, it will cancel after 1 second in this case. That's what you can see if we run this code. It will not wait for 30 seconds, it will wait for 1 second. So if we were to change this millisecond delay to 100 milliseconds instead of 30, it will cancel after 100 milliseconds and not 1 second. So it will cancel after the first one of these linked token sources is getting cancelled. Something you can do is react to the cancellation of a token. So in this example here, we are creating a cancellation token source that is cancelled after 1 second. And then we supply it to a do work function. This function then creates some file and opens a stream to it and simulates some work with two calls. Let's suppose it would be some database response that we would write to a file and some other function that then consumes this file stream. And then we would clean up this file. But if someone would cancel this, we would also want to delete the file and do the cleanup. So what we can do is registering some logic in this cancellation token. That's what we do here. So this cleanup logic is also executed when the cancellation token is triggered. And this in turn will ensure that the file is deleted if it runs normally or if it is getting cancelled. If we change this delay to 5 seconds, for example, then you will see that the request will finish normally and the file is also getting deleted. I hope you have learned something new today, and I wish you a nice day. Bye bye.